so we are on 3.3, page 240. If you look right here, this is the graph for x to the third power. If you look, you put 0 in. Remember, if you can't remember how to make a graph, okay, what's the worst case scenario? If you don't remember all this stretch, compression, if you don't remember all the points that I talked about, vertical dilations or shifts or anything like that, how can you always graph something? Picking points, XY charts, that's what they did here. My function for this one is x cubed equals f of x. So if you plug a 0 in right here, or I'm sorry, 0 in here, 0 cubed is what? And so that's why they got 0, 0. Are you following me? You should be filling this out in your book. And then if you plug a 1 in, 1 cubed is 1. And 2 cubed is... Now, let's do this a little bit farther down, because I don't know why they didn't do this, but we're going to do this for right here. What if I put a -1 in? What happens when you put a -1? Since it's cubed, it's going to stay negative, and actually you get a -1 out. And if you put a -2 in, what do you get? A -8 out, which is why they plotted those points right here and right here, and that's how we developed this shape that looks like this. The worst case scenario, you need to go ahead and make an X and Y chart, no matter how ugly the function is that you're trying to graph. Plug in X's, solve for Y's.
So if it's like an odd exponent, like, 3, you have, like, if you know it's going to start down and go up like that, you have to put in, like, -6.
Yeah, because if you would have just done this, if you had only started at 0, you would have only got part of the graph. That's why in behavior we know eventually this thing needs to start going down forever. And once I see that it's starting to go down forever, I've got every piece of this graph, right? I've got the end here, I've got the middle here, and I've got the end here. So I've got a good, remember, graphing it, we're not doing it exact. We're just giving a pretty good visual representation of the answers. All right? So that's what this is going to look like. So if you notice, this guy is symmetric about a point. With me from yesterday, it's symmetric about a point because if I go from here, I go over 2, I go up 8. Well, if I go back 2, I go down 8. Remember, it's symmetrical about that point. And then basically all I wanted to go over with this is, the other day we were in quadratics. What form would this be in if this was in quadratic? This right here, the g of x. Say louder. Vertex form. Vertex form was the thing that gave me all my shifts, my compressions. It's so if I have this right here, what do I know this guy's going to do? Let's see. What does the C do? It moves it left and right. It's a horizontal shift, and it does it the opposite way. With me. What do I know about this guy? This one is a horizontal shift, which means it moves it left and right. What is this? It's a D. Vertical shift, and it moves it the way I think, and it moves it up and down. This is a stretch or compression vertically. This is a stretch or compression horizontally. Remember, whatever I do in here is going to be the opposite. So if you look, they say when A is greater than 1, it's a stretch. But look at B. When B is greater than 1, it's a compression. Do you remember how I told you to think opposite of this? You with me? Well, here's what they're trying to tell you. If you even have f of x, and it's something like 5x minus 3 squared plus 2. remember when I'm sorry, not squared. We're making this cubed now. Cubed. That's the whole point of this. It's talking about it being cubed. If you have it in this form, do you remember all that stuff you learned from quadratics? It rolls over. What is this going to be? It's a horizontal, right? Horizontal shift. This is a vertical shift. So you remember my 0, 0 number? Remember if I go back to my parent, it was 0, 0, right? That was my reflected one, where it kind of, the point of symmetry. My point of symmetry is moved now. It's right here and right here. You with me? So guess what I know my point is going to be for this one? It would be 3, 2. Check and see if that point works. How can you do that? Plug it in. What is 3 minus 3? Cubed. 0 times 5. 0 plus 2. 0 plus 2. Did I get a 2 out? Yes. Did I already predict that that was going to be an ordered pair? By using my shifts. Not only do I know that that's my shifts, but I know that this is where this is going to be that point where it starts changing. It's that reference point that we were talking about. Do you remember when I was up here? What's my reference point on this one? What's my reference point here? My reference point is 0, 0. Because that's the point where I start going, well, if I go this way 1, and then I go up 1, then I go this way 1 and down 1. You with me? That's the reference point. Where's my reference point for this one? Right there at 3, 2. So I know that's going to be like my, what did we call that when it was parabola? We called it the vertex. We're not going to call it a vertex because it's not going to necessarily be the loop, but that's kind of like the vertex. Are you with me? What else do I know about this graph? What does the 5 tell me? The really thing I want you to know is that it's a stretch of 5. So normally, my S kind of look, or my cubes look like this, yes? Well, what is 5 going to do that thing? Notice that it got what? Skinny, almost straighter, right? Because it's shooting, it's straighting. It's like I'm pulling this up and I'm pulling this down, so it's going to make it more straight. The bigger the number, the more straight it's going to look because it's going to shoot up much faster. The smaller the number, the fatter it's going to start looking, more like an S. Like, you know what I mean? Well, eventually it starts hooking back up, but it starts widening out. You with me? Yes? All right. All this is doing all that we just talked about. The next biggest point, like I said, this is not too much that I really care about from this. If you want to go back and fill these charts in, I'll kind of leave them on the videos. If you want to go back and fill them in, you can fill them in. But we've already talked a little bit about all this stuff. Here's the other one. If you want to fill it back in, you can fill it in. Notice it's the same thing for if it's to the quarter power. This is the page I really want to get to, is the talk to talk. So if you're going through, you can get to talk to talk. Actually, I like to stop at this one, which is page 252. Right here. Polynomial functions can be written like this. And all it's telling you is you have to start with the highest x and work your way to the lowest x. So if you have a function like this, f of x equals, we normally do like 5x to the 6th minus 4x to the 3rd minus 2x squared minus x plus 7. You see how it's going from 6, 3, 2, technically that's a 1. It's actually even. Can the 7 have an x next to it? It actually can. What could x be written back here that would not change that value, but just change the way it looks if it was to the what power? Y. What is anything to the 0 power? No, it is not. Anything to the 0 power is 1. So what is x to the 0 power? 1. And what's 1 times 7? So have I changed that value by writing it like that? Remember, that's what we do as mathematicians. We see things, and that's for later on. I'm prepping you for something. Just kind of having that understanding that this is really x to the 0 power. Okay? That might not even be for you, but that's kind of something that you will need to know for calculus and things like that. Just little preps like that for later on. You with me? All right. So here's what happens. A quartic, right here, quartic function is known as something to the 4th power. A quintic function is something to the 5th power. Remember, when I say that, that means that that's the highest power. So the highest power that a quartic function could have is x to the what power? 4th. Could it have a 3rd in it? Yes. Could it have a 2nd in it?
Yes.
Could it have a 5th in it?
No.
No. If it had a 5th in it, we would classify it as a quintic. Are you with me? Okay. So now let's look at this from yesterday. This is where it gets real good. Based on yesterday, do you see this in your book? It's probably too hard to read up here, but do you see that in your book? It says, number 1, consider this polynomial function. Predict what the graph looks like. Describe the number of x-intercepts. Okay. How many x-intercepts could this thing have? Okay. Remember, it's only the highest power. It's only the highest power. So how many could it have? Possible of 3. Or what else? 2. 1. Could it have 0? Could it have 0 x-intercepts? Think through this. How many? So let's think of the cases, because there's pieces. We're piecing it together. This is where you're actually going, I'm thinking through stuff. I'm not just guessing anymore. Okay? If it has 3 roots, how many real roots would it have? How many real roots would it have? 3. Is that possible? Can something intersect the x-axis 3 times?
Yeah.
Yes, it can. It's allowed to have loops in it now. We're not in straight lines anymore. That's algebra 1. We're past that. Can this thing hit the x-intercept 3 times? Yes, because that would mean it has 3 real roots. Are 3 real roots possible? Yes. Could it have 2 real roots?
Yes.
Yes. What would have to happen if I only had 2 real roots? One of them has a what? It's a word I've been trying to get you guys to understand. One has a multiplicity of 2. So it would still have 3 real roots, but one would count for 2 of them. Could it have 1 real root? Yes, there's actually 2 different cases for this. Think about it. It could have 1 real root and what? Multiplicity of 3. That works. What's the other case? It could have 1 real root. Why now could I have an imaginary? What do imaginary numbers have to come in? Pairs. So So if I have one real root, I would have to have what? 2 imaginary. What's that total up to? 3. Are we good so far? Are you making sense with this? Now, let's think about 0. But to go to 0, I'm going to have to think of my end behavior. Do you remember my odds? What do my odds start? They can start up, but they have to eventually finish what? Or they can start, and they have to end. Are you with me on the 2 cases? How the heck, if I go to infinity this way up, and I go to infinity way this down, how would this graph ever miss the x-axis? What if the x-axis is up here with this graph? What's it eventually going to do? It's got to run into it. What if the x-axis is down here? What's it eventually going to do? Because this thing goes down forever. Forever. No one? Alright, so it goes down forever. It has to run into the x-axis, or it goes up forever. So it would have to run into the x-axis. So what do I know about this? It has to have what? At least one real root. It would have to touch the x-axis. You with me on that? How many times did this graph touch? They actually used the graphing calculator and put this graph in, and you see it's got 3, and what roots are they? What kind of roots are they? 3 real roots. You with me? Oh. Alright, here's the real deal. This is good. This is probably the best thing for today's lesson. What do you know about linear functions? What is x to the power of? 1. X is to the power of 1. How many roots can this thing have? 1. And it has to have 1, right? Because eventually this thing is going to have to run into the x-axis, because here it's either going down forever, going up forever, going up forever, going down. It's got to run into the x-axis. You with me on that? How many does this have to have? Well, let's watch how I can do this. Watch how I draw this. Did you see if I draw my x-axis right here? How many roots does it have? 2. What if I draw my x-axis here? How many does it have? And what if I draw my x-axis down here? How many does it have? Does everybody understand? This quadratic is x to the second power, and it can have 2, 1, or 0. And when I'm talking about roots, which are x-intercepts. Yes? That's going to be a constant function. That's not going to be x and y. Do you get what I'm saying? That's a very good question. That will be a y equals 5 graph. Get what I'm saying now? Alright. Cubics. How many times could this thing intersect the x-axis? So this is x to the third. How many times could this intersect the x-axis? 3 times. Could at least do it, right, once. Could it hit it twice? Yeah. What if I drew it right there? How many times did it touch? Twice. What would that mean one of those roots has to have? A multiplicity of 2 at least, right? Or not at least, it has to have a multiplicity of 2. Because I'd have this counts as 2, this counts as 1, boom, I've got my 3 roots that I need. You with me? And then what would be my final case? Right there, 3 times. What do you know these functions? After this, what do you start to see? What does a quartic function start to look? What can it look like? What do these guys look like right here? Don't they look quadratic?
Yeah.
What does quintic start to possibly look like? So everything after can look like all the ones before, and then you just add some loops. We're going to talk a lot more about the loops, this part, tomorrow, and throughout the year. You with me? But how many times, so to the fourth power, how many times can it hit? Hit it 4 times. Does everybody see, like, if I drew that right there? What else? 3. Like that, where it hit right here. 1, 2, 3. What else? What if I just drew this there, or even like that, right? There's a bunch of different cases for 2. What else? Could it hit it just 1 time? Yeah. What if I drew it like right there, in that case, or if I drew it right there in that case? And what else? What if it's down here, right? For this one right here. It'll never touch 0 times. Those are just the possibilities. You with me? Alright. You can go ahead and I think we got the gist for that. We're going to check the homework. So go ahead and get your homework out. We'll talk about that. Alright, so here's the homework. If we had something to the 20th power, what is my A? It's positive. What is my N? Even. So I'm going to be, if I can spell even again, I'm going to be on that one case. It doesn't matter how you draw this. I just know that it's going to be what? That's what they were going for. Just the end behavior. You know it's going to start up and end up because of that chart. Alright? What do I know about this guy? Since my A is what? So I've got a negative and a odd. What does that tell me? Start up.
We're going to start down. Start up.
Well, which one? It's not a guess. It's one or the other. Look at the chart. Which way does it start? Right. If you can't remember, how can you check to make sure that you're right? Plug a point in. What if I do something on the negative side? What's negative 1 to the 5th power? But what happens when I take the opposite of that? Because remember, I told you when you plug in, it looks like this. This is where we're getting a hard time. That is negative. That is this negative right here. Put a negative 1. That is from right there into the 5th power. Which one goes first? My power goes first. Negative 1 to the 5th power is a negative 1. But I've got this negative out here, and a negative and negative make a positive. That's where we're getting things wrong on our tests a lot. We're doing silly things like that. So this, if I put a negative 2 in, it's going to be out of the roof. This thing is going to be so high because it's to the 5th power. But I know that it's going to start up, and it's going to end down. That's all I needed you to know. That's from the chart. The chart should say if it's negative and odd, I know on my left side, it starts up and it ends down. You with me? Alright. Even or odd? I know this is odd because it's symmetrical about the origin. What about this guy? Neither, because it's not symmetrical about the origin. This one would be neither. Remember, it had to be for even or odd, it had to be around that. This is the one I really wanted to get to. If I was checking this, if it's even or odd, first thing I try is f at negative x. I see, does it equal the same thing? 5 negative x squared plus 13. Because it's to the 2nd power, what does that really make this? No matter what happens. It really makes it a positive, so it didn't change its sign. Is this the same thing as this? So then this one was even. Alright, here we go. F of negative x equals 3 negative x to the 5th minus negative x. That becomes negative 3x to the fifth plus x. Yes? And is that even? No, it's not. So I got to check negative f of negative x. I get to cheat this one. I just put a negative out here, bubble, and I put what I got right there. Negative 3x to the fifth plus x. Distribute this. 3x to the fifth minus x. Is not what I started with. So what is this function? Is that it? Does that make sense? Questions?